In this question, it is given that let P1 and P2 be two planes given by this and this. And you have to find out of these lines, which of these lines can be edge of some tetrahedron whose faces lie on P1 and P2. See, this is the shape of tetrahedron you must be knowing. And according to me, this is the best question on mathematics in paper 1 of JEE Advanced 2022. You will find that my solution is crystal clear solution. You know that this is the shape of tetrahedron. Suppose this is the plane P1. That is, suppose the vertices are A, B, C, D. And the plane ABD I have named as P1, and the plane BCD I am naming it as P2. That is these two planes. Obviously, this BD will become the one of the edge of the tetrahedron. That is, this line is the line of intersection of these two planes. That is, if we convert this line in symmetrical form, you will get the equation of the line BD. And you have to find out of these lines, which of these lines can be this edge or this edge or this edge or this edge or this edge. We know that one of the edges clearly BD, and we have to find which of these lines can be edge of the tetrahedron. You can see very easily that out of these remaining 5 edges, you can see very easily out of the edge AB, AD, BC and BD, out of these 4 edges, each edge either lies on P1 or on P2, and this is the edge which is lying both on P1 and P2. Edge AC neither lies on the plane P1 nor lies on the plane P2. I am speaking about the edge AC. That is, we can say out of these 4 lines, only that line can become the edge of tetrahedron if that line completely lies on P1 or completely lies on P2. That is, out of these 4 lines, only that line can become the edge of tetrahedron if and only if situation is that that line completely lies on the plane P1 or completely lies on the plane P2. If that line completely lies on the plane P1, then that line can become this edge or this edge. Or the other possibility, so that the any of these lines can become the edge of tetrahedron. The other possibility is the line completely lies on the plane P2. In that case, line can become this edge or this edge. Or the last possibility is the line cuts both the planes P1 and P2. That is, we can say that a line can become edge of this tetrahedron if it is of the type AB, AD, BC or BD, or it is of the type AC. What I mean to say, the line is completely lying on the plane P1, then it will be of the type AB or AD. Or line completely lies on the plane P2, then it will be of the type BC or CD. Or the line is of the type AC. That is, line is cutting the plane P1 and P2 at two distinct points. If some line is cutting the plane P1 and P2 at two distinct points, then that line will be of the type AC. Now you must have understood the way of doing question. But the next problem is how to use this theory for doing question. Now I will give you three alternative solution of this question. In every solution, I will be using the same theory. The first way, as I have told you, that line can become the edge if that lies completely in the plane P1 or completely in the plane P2 or cuts the plane P1 and P2 at two distinct points. Hence, using the first possibility, first I will check that whether this line is parallel to P1 or P2. If the line is parallel to P1 or P2, then it should be completely inside P1 and P2. And it is very easy to check for some line to be parallel to some plane or not. The direction ratio of this line are 0, 0 and 5, and direction ratio of normal to this plane are 10, 15 and 12. This line can be parallel to this plane only if this line is perpendicular to the normal to the plane, and you know that for checking the perpendicularity you will find the value of 10 into 0 plus 15 into 0 plus 12 into 5. This is non-zero, hence this line is not parallel to this plane. To check this line to be parallel to this, the direction ratio of normal to this plane are -2, 5 and 4, and direction ratio of this line are 0, 0, 5, and this line will be parallel to this plane if this line is perpendicular to normal to this plane. And for checking it clearly, -2 into 0 plus 5 into 0 plus 4 into 5, and clearly it is non-zero, hence this line is not parallel to this plane also. That is, this line cannot be of the type of the edge AB, AD, BC or CD, but it can be of the type of the edge AC, but the only condition for that is this line should cut these two planes at two distinct points. If this line cuts P1 and P2 at same point, that will mean that AC is cutting the line BD, and in that case tetrahedron will not be formed. And therefore, let us check this line cuts these two planes at two distinct points or not. To check this thing, first of all, find any point on this line. That you can find by taking it equal to, say, alpha, and you'll get the value of x as 1, y as 1, z as alpha plus 1. And now we'll put this point in this plane and find the value of alpha, and after finding the value of alpha, putting back the value of alpha, that will give you the point where this line cuts this plane. That is, I get 10 into 1 plus 15 into 1 plus 12 into 5 alpha plus 1 minus 60 equal to 0. That is, I get 10 plus 15 plus 12 minus 60 plus 60 alpha equal to 0. that is alpha is equal to 23 by 60. Actually, it is not required to put back the value of alpha and find the point of intersection. I just want to find that this line cuts both the planes at two distinct points or not. And proceeding similarly to find the point where this line cuts this plane, we'll put it equal to beta and we'll get the value of x as 1, y as 1, z as 5 beta plus 1. And similarly proceeding as here, we'll put that point in this plane. That is, because the value of x is 1, y is 1 and z is 5 beta plus 1, just like when alpha was there, we had got this point. Now putting this point in this plane, I get minus 2 into 1, 5 into 1 plus 4 into 5 beta plus 1 minus 20 equal to 0. That is, I will get the value of beta as 13 by 20. Clearly, putting back the value of alpha as this or beta as this, the points I will be getting will be different. Hence, I can say this line can become the edge of the tetrahedron and that edge will be of the type AC. And to check the choice B, again as in previous case, first I will check whether this line is parallel to this plane or not. Clearly, direction ratio of this line are minus 5 to 3. Direction ratio of normal to this plane are 10, 15, 12. Hence, this line will be parallel to this plane if this line is perpendicular to normal to this plane. That is, I will check the value of minus 5 into 10 plus 2 into 15 plus 3 into 12. Clearly, this is equal to minus 50 plus 30 plus 36, which is non-zero. Hence, this line is not parallel to this plane, first plane. Similarly, to check this line is parallel to this plane or not, I'll find the value of minus 5 into minus 2 plus 2 into 5 plus 3 into 4, which is equal to 10 plus 10 plus 12, which is non-zero. Hence, this line is not parallel to this plane. And to check the point of intersection of this line with this plane, as in the previous case, first suppose it equal to alpha, the value of x will be 6 minus 5 alpha, value of y will be 2 alpha and z will be 3 alpha. Putting this point in this plane, you will get 10 into 6 minus 5 alpha, 15 into 2 alpha plus 12 into 3 alpha minus 60 equal to 0. That is, you can say 60 minus 50 alpha plus 30 alpha plus 36 alpha minus 60 equal to 0. That you will get the value of alpha as 0. And to find the point where this line cuts the plane P2, I suppose this equal to beta. Again, I can use alpha also, but for just clarity purpose, I'm using the word beta because I have already told you I want my solutions to be crystal clear. Beta, 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 and beta. And now putting this point in this plane, minus 2 into 6 minus 5 beta plus 5 into 2 beta plus 4 into 3 beta minus 20 equal to 0. That is 32 beta equal to 32. That is beta equal to 1. That is now the point of intersection will be 1, 2, 3. And previously the point of intersection was 6, 0, 0. That is the point are different where this line is cutting these two planes. Hence, the line of the choice B can be again edge of the type AC. Note that these edges AB, BC, AD, CD either lie completely in the plane P1 or completely in the plane P2. But the line AC is neither inside P1 nor inside P2. It is cutting both the planes at two distinct points. Hence, choice B is also correct. Similarly, to check the choice C, let us first check whether this line is parallel to this plane or not. Again, as in previous case, we will find the value of minus 2 into 10 plus 5 into 15 plus 12 into 4, which is non-zero. Hence, this line is not parallel to the plane P1. And now let us check whether this line is parallel to the plane P2. It is clearly not parallel to this plane because it is clearly parallel to novel to this plane. Hence, this is not parallel to the plane P2 also. Hence, this line cannot be edge of the type AB, AD, BC or BD. It can become edge of the type AC if this line cuts both the planes at two distinct points. Again, to find the point of intersection, we suppose it equal to alpha. The value of x I get is minus 2 alpha. Value of y is plus 5 alpha. And value of z is 4 alpha. And putting this point in this plane, I will get 10 into minus 2 alpha plus 15 into 4 plus 5 alpha plus 12 into 4 alpha minus 60 equal to 0. That is minus 20 alpha plus 60 plus 75 alpha plus 48 alpha minus 60 equal to 0. That is the value of alpha is 0. That is this line will cut the plane P1 at 0, 4, 0. And now let us check where this line cuts the plane P2. For that, let us suppose it equal to beta. Agreed. I can suppose alpha also, but for just clarity purpose, I have taken beta because I want my solution to be crystal clear. The value of x is minus 2 beta. Value of y is 4 plus 5 beta. Value of z is 4 beta. And now let us put this point in the plane P2. I'll get minus 2 into minus 2 beta plus 5 into 4 plus 5 beta plus 4 into 4 beta minus 20 equal 0. That is 4 beta plus 25 beta plus 16 beta plus 20 minus 20 equal 0. That is beta equal to 0. Hence this line cuts the plane P2 also at the same point 0, 4, 0. That is, the situation will be of the type the line of the choice C will be cutting the line BD at the point 0, 4, 0 by putting the value of beta as 0. Hence the choice C cannot be correct. And similarly, to check the last choice, again as in previous cases, first I will check whether this line is parallel to the plane P1. Note that if the line is parallel to the plane P1, then it will have to lie in the plane P1. Then if it is lie in the plane P1, then it can become edge provided this line is not parallel to the line given by these two planes. That is, the line is not parallel to the line BD. And to proceed further, whether this line is parallel to the plane P1 or not, find the value of 10 into 1 plus 15 into minus 2 plus 12 into 3, which is non-zero. Hence this line is not parallel to the plane P1. And now check whether this line is parallel to the plane P2. For that, find the value of minus 2 into 1 plus 5 into minus 2 plus 4 into 3, which is 0. Hence this line is parallel to the plane P2. Therefore, this can become the edge if the line completely lies in the plane P2. That is, in this case, even if one point of this line lies in the plane P2, then this line will completely lie in the plane P2. Clearly 0, 4, 0 is a point on this line, and 0, 4, 0 is clearly satisfying this. Therefore, this line completely lie in the plane P2. And this line cannot be parallel to the line BD, because if this line is parallel to BD, then it will be parallel to the plane P1 also. But we have already seen that because of this non-zero, the line is not parallel to the plane P1. Hence, the line cannot be parallel to the line BD. Hence, we can say line of the choice D can be of the type BC or CD.